Well, I don't know. This is the input from the exciter going to the tuned input, and I don't know whether this lead broke off while I was cleaning things up in here, whether it was just hanging by a thread or whether it was already broken. I suspect that it just broke while I was working in here, but if it did, that means it was just hanging by a thread, and you know, no wonder this guy had problems in here. So this is what you find, and when you're cleaning and working on a radio, you can discover problems like this, and if you're not careful, you can also cause them. So now I've had to undo both of these coax leads and the ground. I got to pull it down through the wire, get it on the other side of the chassis so that I can trim back this center conductor and extend it a little bit so I can get on that switch, because it's all chewed up. I really didn't want to spend an hour or two making a whole new cable to replace this. So what I did is took a piece of the coax that was originally been removed from here and spliced on the center conductor. I'm sliding the cover, this is the RG58 cover, over the splice. Hard to do this with one hand. Until it gets all the way down here. So there's the cover slid over the splice. Then I'll take a piece of heat shrink and put that over the cover and heat shrink that on, because the heat shrink I had was too big anyway. That'll hold that cover in place, and that'll be secure, and I'll be able to, I've extended the end of the center conductor enough so I can get it back on the band switch, and Bob's your uncle. Well, 10 minutes beats 2 hours, and it's going to do the job. Well, that cable was out of there. It afforded an opportunity to get in here and clean this input circuit. These are the tuned inputs here connected to the band switch on this side. Not an easy thing to get to when the panel is here and the meters are in and stuff. Very difficult to get in there, so afforded me an opportunity to get in there and clean. Going to be fun trying to get this nut back on here. I had to push this switch in to get a nut driver in there. I guess I'll try to put the nut in the nut driver, see if that'll do it. I wish I had the old Heathkit nut starter. Remember those? Like we said, we're missing a terminal right here off this terminal strip. So what I'm going to do, I've got a little piece of one right here that I happen to have in the drawer. So I'm just going to hot glue it right here in this place, because I don't know what else to do. It gives a little standoff for the leads so they're not hanging in space there. About the best I can do. Okay, well there it is. Seems like an odd thing to do, but before you had a resistor and two capacitors soldered together and hanging out in space. The wires just flopping around, and one end of it was connected to this band switch right here. So that was going to put some stress on this terminal. These terminals are not terribly robust. So this will provide mechanical support for the components, take the strain off of the band switch wiper terminal, and keep the leads from flopping around. So I think it's a perfectly good solution. I don't know why it's any better or worse than this part of this phenolic thing is just crimped in there. That's all it holds that in. So this is going to be as strong as that. And so there we go. In the past, you know, doing old 30s and 40s shortwave radios and stuff where you're putting electrolytic capacitors in the bottom of the chassis, but leaving the old ones attached to the chassis for cosmetic purposes. We would glue those things in to keep them secure when we needed to. So rather than just have them flopping on the leads, it's good to tie them down somehow. So just in case you're doubting Thomas, that's how strong it is. You can bend the metal and if you want to. So you know, it's just as good as if it were screwed to the chassis, and there wasn't any point in doing that anyway. Okay, well, we got this done. Not beautiful, but it's better. We replaced this resistor. This was supposed to be 2200 ohms, and it measured 3300. It was 1,000 ohms high. We replaced it with 2110, so it's 90 ohms low, but it's a lot closer. We decided this 10 puff capacitor was okay. We replaced this 0.001 disc ceramic with a new capacitor because the other one was just ugly and funky. So anyway, got rid of the solder blobs. Sure, not the way we would have built it if it was original, but this is what we had to do. So we've got this squared away now. Wire address is okay. Wire leads are okay. Fixed that piece of coax. So that should all work okay. Thing that drives me nuts about this design is that, you know, you'd like to be able to tune the input coils to make the amplifier work the best it can, but you can't get at them unless you take the flop the front panel off. There's high voltage wires here. There's the metering wires aren't very long. It's a very strange kind of design. I don't really understand that. In the SB200, you can take it out and they're in the back, and you can get right to them, so you can apply power to the thing and peak the drive up and make sure it's presenting the load you want to your transceiver, and peaked on the part of the band you want and all of that, yada yada. So I imagine they're fairly broad-banded, but still, you'd like to have some kind of access here without taking everything apart and having things flopping around on the, take all the knobs off, take the panel off, yada yada yada. So I don't know, I guess we'll figure it out before we put it all back together. Okay, there's supposed to be a 500 picofarad mica cap between ground and these two terminals on the band switch. When you switch to 80 meters, it switches in 500 picofarads more capacitance in parallel with the loading caps. Well, that was missing in this transmitter, and somebody had a big variable receiver capacitor in there with some weird wires. So we took that out, and what I've done is I've fabricated this. This is a real mica transmitting cap. This thing's rated at 2500 working volts, 5000 peak. It's 600 picofarad. But I didn't have a little molded one with wire leads to put on there, so I've fixed this thing, and it will go in here like this, and this copper wire will go in the terminal, and that'll ground it, and the other end will this blue wire will go through those two terminals, and that'll be that. Well, there it is. 600 picofarad mica cap, and this copper lead is attached to a screw terminal on there. That's really holding the weight of the capacitor. And then there's a flexible lead that goes to the switch, so that if this thing moved around a little bit, it won't put torque on that terminals of that switch. So that's what we were able to do, and should work just fine.